Hi, welcome to one of our so many quarantine lectures. Today we're going to go over section 7.4 along with continuing our review for our next exam 3. So let me go ahead and share my screen. All right. So I'm sharing the screen and we're going to jump over to 7.3. Maybe just we're doing 7.4. All right. Let's go ahead and go over this section. We're going to do a lot of signs for the next section. I think this section is also fairly quick, so it should be fairly a fun section to go over. Let's go ahead and start, and then we'll go over the review. So section 7.4, applications involving right triangles. In this section, we apply the knowledge of solving right triangles to possible real-world situations. For each, we identify the triangle that can be drawn and label it with the given information. We then use right triangle trigonometry, so your trig functions, and a calculator to find the requested measurements. Note 1, because these applications are in sentence form, it's appropriate to write the answer in sentence form. And note 2, as default, we will round each measure to nearest tenth, so just 1 decimal place, unless otherwise indicated. Example 1, the city has decided to put in a new road, Curzon Way, between Beach and Adams. The distance from point A to point C is 1.5 miles. The distance from point B to point C is 3.6 miles. And we see an image right there, what's going on. So let's go ahead and write down what we have. The distance from A to C is 1.5. And the distance from B to C is 3.6. Give me 1 second. Participants, mute off. There we go. So I don't hear your TV on the background. So we set that A to C is 1.5 miles. The distance from point B to C is 3.6. All right, great. Question A, what will be the length of Curzon Way? Well, Curzon Way is this one right here, so this is our unknown. Okay, well, it's telling us that we have a right triangle. It gives us a little right triangle symbol, a little box. So we know to get that side length, we can just continue with Pythagorean theorem, as we see here. We enter the measurements of the 2 legs because our missing length is the hypotenuse, that BC. And we get that C is about 3.9. So we write that down. Now B, what angle will Curzon Way make with Beach? So this is the next part it wants. This is the angle that it makes with Curzon Way and Beach. Well, we can use our triangle trigonometry as your book states. Now we can use whatever we like, but keep in mind that we have that x as our perspective, as our eye view. So here it does tangent, and we'll see what it has. And we know that, I'll make a little note that tangent theta is made up of opposite over adjacent. So let's label those pieces. Opposite over angle x would be 3.6, and adjacent would be 1.5. 3.9 is a hypotenuse. Though it is adjacent, it's a special type of adjacent, so don't forget that. So we have set up that tangent of A is 3.6 over 1.5. You don't have to simplify it, but if you do, you get 2.4. And to find the value of A, we do tan inverse on both sides. And that gets rid of this tangent. That's the algebra behind it, but it doesn't, we didn't go over that. So you just take the tangent inverse of the other side so you can get your final answer. And you round to one decimal place. All right, go ahead and try in class example 2. We'll read it together. ABC is an isosceles triangle. So we know isosceles triangles, they have two of the same measurements, right? With altitude CD, and the measurement of C is 110. So all of this is 110. And each congruent side measures 15 centimeters. Note the altitude is perpendicular to the base AB. What is the altitude of H of the triangle? And B, what is the length of the base? All right, so we want to know for B. For B, we want to know the length of the base, that measurement. And for A, we want to know the altitude of the triangle, so we want to find H. So the two things we want to find. And it tells us that each congruent side measures 15 centimeters. So I think it's telling us that that's 15 and that's 15. So can we go from there? This one's pretty hard. Let's do it together. So if you like to, it's some things are told that are implied. So we have a perpendicular base. So this tells us that we have a 90-degree triangle right there. And we want to find our side lengths. We have some cases, if we're told that this whole angle is 110, and if it's perpendicular, it splits it in half, right? Directly in half. So 110 divided by 2, we get 55 and 55 for each little angle. So we know we actually have our triangle solved, right? We have 90 degrees here. We have 55. And so we have 180 minus 55 minus 90. We get that this is a measurement of 35. And this will be the same because we have an isosceles triangle. Now, we just need to find the parts that are in purple and blue that we have highlighted. We can go ahead and do that using our triangle trigonometry. So let's take a look at A. What is the altitude of H? Okay, so pick any angle that you want to work with. Let's say 35 degrees. I want to find H because that's my X, that's my unknown. And I want to work with this 15. So that would force me to work with opposite and hypotenuse. What trig function works with opposite and hypotenuse? And that would be sine, right? So we can say sine of 35 is equal to H over 15. And now we can go ahead and solve H. We can do some algebra. We can multiply both sides by 15. That makes 1 times 15. So that we're left that H is equal to 15 times sine of 35. Let's go ahead and compute that. So use your calculator. For my calculator, first press sine and 35, find what that is, and then write times 15. So my answer for H is 8.603646. We want to round to one decimal place, so we say 8.6. All right, let's take a look at B. Find the base of, what is the length of the base? All right, so we found that H is 8.6. You want to find the length of our base. And if it's perpendicular, it's right in the middle. So I just need to find one, and the other one will be the same measurement. So from there, I can just add them to continue. So I want to work with something where I'm working with this unknown side because I don't know what it is. So if I work with the angle, let's say I want to work with 35 again, what angle would deal with an adjacent side and the hypotenuse? That gives you cosine or secant, right? It would just be the flip of that. So we can do cosine of 35 is equal to, cosine is adjacent over hypotenuse. Adjacent would be y, and hypotenuse would be 15. All right, we do a little bit of algebra to get y by itself. So times 15 times 15, that's now gone. So we're left with y is equal to 15 times cosine of 35. Now, if you don't have a calculator handy, your cell phone does a lot of this. You just, if you turn your cell phone to the side, it gives you more functions, and that's where you can access your trig functions. So we punch in cosine, not cosine inverse, just cosine. Cosine of 35 times 15. And we get that y is equal to 12.28728, and it continues. You want to round to one decimal place, 12.3. Well, that's not an answer, so let's not box that. So y is 12.3, and we want to find the measurement of the entire base, so we have to multiply it by 2. 12.3 times 2, we get 24.6. Not y, our entire measurement.
I got that answer, but I did something else entirely.
Okay, what'd you do?
I just used the Pythagorean theorem.
Yeah, you can do that too.
I did. I know we have 15 is the hypotenuse, and then we have one of the sides is 8.6. So.
And yeah, I didn't mean to cut you off. I'm sorry.
That's fine. I mean, I think you know where I was going with that.
Yeah, and I think that's one of the cool things about math, and what kind of makes it so beautiful is that if you're following the rules, then you will get the same answer. It's all a matter of following rules, right? So we can use our trig functions, and that lets us work with our side measurements or also our angles. But if we're just looking for sides and we have 90-degree triangle, you can always do Pythagorean theorem. It just depends what you catch first. All right, let's move forward. If for some reason, I want to make a quick note, if for some reason you're not getting these values, but you're punching into your calculator right, it could be that you are in radians and not degrees. So make sure you're in degrees. And the reason we're working with degrees is because as we see our triangle, we're looking at the degrees of triangles, and that's why we're working with these trig functions, not radians. Angles of elevation and depression. An angle of elevation is the angle between a horizontal ray and a ray or line segment going upward. The angle of depression is the angle between a horizontal ray and a ray going downward. So that it gives us an image of angle of depression and angle of elevation. For example, when Romeo is standing on the ground and Juliet is standing on a balcony, the angle Romeo needs to look up to see Juliet is the angle of elevation. However, from Juliet's point of view, the angle she needs to look down to see Romeo is an angle of depression. Really, it's the same angle, or at least the same angle measure, in other words. The angle of elevation is congruent to the angle of depression. Why are these angles congruent? Well, I think that's just a question that can take you back to chapter 1, where we did 2 parallel lines and a transversal, and you learn about your alternate interior and all those different types of angles where it's the same two angles over and over again. In class example 3, at 3 o'clock, the shadow of a flagpole is 9 feet long. The angle of elevation of the sun is 62. How tall is the flagpole? All right, so the shadow, it tells us here the shadow is 9 feet. The angle of elevation of the sun is 62. So elevation is the one down here, right? So the angle of elevation is 62. How tall is the flagpole? Okay, well, we have bits that we can work with, and it's a matter of us putting all these pieces together in a puzzle so that we can kind of get a better idea. A wants us to label a diagram at right, use H for the height of the flagpole, so we'll do an H, and place the known values in or around the triangle. We did that as we read it. B, use trigonometry to find the measure of H. Okay, so work with the angle you know. We know we were given an angle of 62 degrees. So why don't we stick with that only? So if our eyesight is at the 62-degree angle, and I want to solve that H, and we're given that 9, what trig function can I use using, now I have to think, what is this? This is according to my angle, from my angle, this is opposite. And the 9 feet, which is the other piece I was given, is adjacent. What trig function can I choose that uses opposite and adjacent? You have two options. You have tangent, right? Opposite adjacent, or it's reciprocal, cotangent. They will both work. It's just a matter of picking one of them. All right, with that set up, we can set up our equation and say that tangent of our degree, 62, is equal to opposite and adjacent. Our opposite is H, our adjacent is 9. So now we can go ahead and solve for our unknown, which is H. So to get H by itself, you have to do some algebra. We can multiply by 9, that makes 1, multiply by 9, so that we're left with 9 times tangent of 62 is equal to H. Now we just punch this into our calculator. So tangent of 62 equals times 9. We get 16.926538819. That's H. We want to round to one decimal place, so we can say that H is 16.9. Now, if we want to be extra proper, because we have a word problem, we have to answer as a word answer. So our question is, how tall is the flagpole? We can say the flagpole is about 16.9, and what's the unit of measurement? Feet. And that satisfies our question. Now, before moving forward, any questions about this?
Not this one. Word problems are a little tricky, but I think it's pretty straightforward.
That one's pretty straightforward?
Yeah.
I have a question, but
yeah.
Do you mind scrolling up to example 2 so I can take a picture, please?
Yeah. There you go.
Yeah.
Through all that chicken scratch.
Okay,
right.
Thank you.
Okay. Moving forward, in the end, solving these types of applications is no different from solving right triangles in general. For some, you might need to draw your own diagram. For other applications, the diagram is given. But if it contains more than one triangle, it is up to you to separate the label of different triangles. In this case, it's important to identify the common measures between two triangles, such as a shared side. It's also important to read the application problem through more than once. First, you get a general idea of the situation. Second or third time to identify important information to help you draw and label the triangle. Really, read it at least a minimum of 5 times, because especially when it's new, it doesn't always make sense the first time, and that's okay. And that's something that is totally ignored in the math class. Sometimes when we're going through it, we kind of rush, or we might not give it as much time as we should, but it takes a lot of time. It takes a lot of reading. So read it once, twice, 3, 4, 5 times. You just keep on reading it until something makes sense. All right, so this was it for this section, super short. Let's do some problems together. So your assignment for this one is, I think odds is fine, all odds. There isn't too many, and I don't want you to be stuck doing this forever, but yeah, so you have up to 7. So you do 1, 3, 5, 7, 4 problems. Not bad. I just want you to get practice with wording and how things work. So it's 1 through 7.
All right.
Yeah. All right. Let's do 7. Usually, I think that as you continue through the section, they get more challenging. So let's do 7. Hopefully I don't get stuck. Probably get stuck. Okay. Number 7. Refer to the diagram at the right, or at right. At a vertical cliff, 2 rocks align with the base of the cliff, as shown. All right, I see the rocks. Cool. The farther rock is 74 feet directly behind the closer one. That makes no sense to me. To the top of the cliff, the angle of elevation from the closer rock is 68. And the angle of elevation from the further rock is 35 degrees. Okay, so I read it once. I didn't really, I'm seeing it like, okay. So my biggest question was, which was the further rock, which is the closest rock? And I think it's referring everything to the cliff as to which one's closer and further. So let's read it one more time. At a vertical cliff, 2 rocks align with the base of the cliff, as shown. The farther rock is 74 feet away. Okay, I see the 74. Behind the closer one, at the top of the cliff, the angle of elevation from the closer rock is 68. Okay, it marks the 68. And the angle of elevation from the farther rock is 35 degrees. All right, I see that everything's labeled. I get it a bit better this time. How far from the bottom of the cliff is the closer rock? So we want to find H. All right, so my question, is 74 all of this, or is 74 just that? I think it's just that, right? Because we have this X here. We have that X here. So I'm guessing from here to here, it's 74. And then from here to here is called X, right? Can I get a whoop whoop? No? Silence?
It's good to me.
All right. Good? Okay. All right. So I have my 90-degree triangle, right? And I have this angle of 35. So why don't we first try to, I think we first have to work with that larger triangle. To find the measurement of X, create an equation, and then create another equation with H. Use both of them using H. So we have to do one with the green triangle make an equation, and then I have to make another equation with this triangle in purple. All right, so let's make an equation with a triangle in purple using H. So purple triangle. I hope no one is colorblind. If so, I'm sorry. This is one. All right, so if we make an equation using our given angle of 68 degrees, if I want to involve H and X, that would be opposite and adjacent, or adjacent and opposite, however you want to say it. So that would be tangent. Tangent of 68 is equal to opposite, which is H, over adjacent, which is X. All right, now let's consider the green triangle, which is the bigger, both triangles together. Green triangle. If I want to create a similar type of situation, I want to work with H because I'm trying to find, and I'm trying to use this whole part here because that's that whole side. If I'm using opposite side and adjacent side, I also have tangent. Tangent of 35 is equal to opposite over adjacent. Opposite is H, adjacent is X plus 74. All right, this looks like one we did last time. The example one, not the one I failed as an instructor. All right, now I want to solve each one for H, and then I can move on. So let's multiply both sides by X plus 74, X plus 74. That's gone. So we're left with X plus 74 times tangent of 35 is equal to H. Let's do the same thing to the other side. Let's multiply by X to get it out of the way. And we're left with X times tangent of 68 is equal to H. All right, we have our equations equal to the same thing. Can you take a guess at why we're doing this? Our goal is to set them equal to each other.
Okay.
If we say that this is H, well, isn't all of this equal to H? So can't I rewrite it
Oh, yeah.
to be,
Okay.
yeah, totally tricky. X times
Sorry, Professor.
tangent.
I'm seeing it now. It took me a second.
Yeah, it's okay. These take a second. They take me a second. They take me like 3 seconds. A lot of seconds. X times tangent of 68 equals H, but we're saying, hey, isn't H equal to X plus 74 times tangent of 35? And now we can solve it because we have an equation in one variable. So it turns into an equation for solve for X. And while this doesn't solve our answer, it does get us one step closer because we're dealing with two unknowns. So we're trying to connect the puzzle or start building the puzzle as best we can. So let's solve for X. So I see I have to distributive property, so I have to multiply tangent to what's in the parentheses, that's 74, and to the X. So that I have X times tangent of 35 plus 74 times tangent of 35. And on the other side of an equal sign, I have X times tangent of 68. All right, our problem here, our dilemma, is that we have two unknowns. We have two X's. But these two X's are not something I can subtract because they have a different, they're not like terms. I have tangent 68 and tangent 35. It would be like trying to add xy plus xz. Can you add them? No, right? But I want to get x by itself. So what if we take our x's and we divide them out if we factor them? If we do that, I'm left with x times ry plus z. So just a little think box, right? So why don't we do that same idea, but with our tangents? All right, so let's get our x's together. So let's move this x to the other side by subtracting x tangent of 35 minus x tangent of 35, so that we have x tangent of 68 minus x tangent of 35 is equal to what's left over. After I move that, I'm left with 74 tangent of 35. All right, why do we do all this? Our whole idea is to be able to factor out our x's. Let's factor them. If we do, we're left with x times what's left over. Tangent of 68 minus tangent of 35. And it's not something I can subtract. It's a decimal number in disguise. Think of it that way. Is equal to 74 times tangent of 35. Lastly, to get x by itself, let's divide both sides by that mess of tangent of 68 minus tangent of 35. And we're done. We're left with x is equal to, but we still have to punch into our calculator. We have 74 tangent 35 divided by tangent of 68 minus tangent of 35. All right, so how would you punch into your calculator? I would try to use parentheses so I can punch it in one go. So we can do parentheses 74 times tangent of 35 close parentheses divided by open parentheses tangent of 68 minus tangent of 35 close parentheses. Close parentheses. All right. And we get that x is equal to, let's round to one decimal place, 29.2. That's our x. All right, we did all this work to find x. That's not what our answer wants. Our answer wants h. So I'm going to move my work. If you'd like to, this would be a good time to take a picture. All right, so we said we wanted to find h, but we just found x, right? So we have x is 29.2. We want to find h. Well, now it's an easy step, right? I can work with this angle right here. And now that I know that x is 29.2, I can use my adjacent side and my opposite side. And I have tangent of 68. We have it here. Or we can use any one of these. Tangent of 68 equals x over h. And we actually have it set up right here, right? So we can just punch in x, which is 29.2, to get the answer of h. So we have 29.2 times tangent of 68, and that's our answer. 29.2 times tangent of 68. So our answer, x is equal to 72.3. It's 27, right? 72, 27, 25, 36. So it's a long number. So our final answer, h, is 72.3. Now I know this one's a lot. Are there any questions they might have?
Yeah,
Or
I
do you
can't
think-
seem to get the initial 29.2, no matter what I punch into the calculator.
Are you in degrees? Have you been getting the other answers?
Yeah, I'm
All
getting
right.
everything else fine, but this one's not working. So x is 74 times tangent of 35 over tangent of 68. Is it minus tangent 35 or is it times
Yeah,
tangent? Okay, maybe that's what I'm
minus.
doing wrong. I'm doing multiplication.
Yeah, it might be helpful if you put brackets or parentheses around this. And yes, so this is subtraction. I'm going to punch for this is a division sign.
Yeah, still not getting that. I'm getting 21.67. So I'm not entering it correctly, but I can't figure out where I'm going wrong.
Does it calculate like this or is it something else?
It's a TI 30.
I don't know that.
It's
Oh, okay. It's a scientific calculator. Okay, so does it give you a screen when you type in tangent and you see the number?
yeah. So what it does is it gives me tangent with an open parentheses.
Okay, maybe we need to close the parentheses. So let me guide you through it. So clear it out. Do an open parentheses and then type in 74 times button.
Mm-hmm.
Push your tangent button 35. Now I'm guessing it leaves an open bracket once you click 35. Close
Yeah.
it. Okay. Close your bracket. Now close it again
Okay.
to close out your numerator. Division button.
Mm-hmm.
Open parenthesis. Tangent button 68. Close your parenthesis.
Mm-hmm.
Minus tangent button 35. Close your parenthesis and close your parentheses again. Now press enter.
There we go. 29.1937.
Yeah.
Okay. It's,
Cool.
Apparently I have to double close the parentheses.
Yeah, so what it's doing is it's reading that all into your tangent. So you're typing in tangent of 35 divided by, so that's what you're typing in. You're typing in tangent of 35 divided by tangent of 68. Because it's all within that first tangent.
Okay. Yeah, I get what you're saying.
Yeah. But cool. Maybe someone else had that same question and just didn't want to voice it out. I see the chat's good. There's no questions there. All right. If there aren't any objections, let's continue with our review.
Alrighty. Professor,
All right.
I came in a little late. I missed the first 5 minutes. Did I miss anything or did you just jump into this section?
I just jumped into the section, yeah.
Okay, sounds good. So we're going to hit the review next?
The review next, yes.
All right, perfect. Thank you.
Cool. All right. So, where are you? Here you are, pretest. So we stopped at 6. All right. Our question says to find all degree solutions for theta.
We also skipped over 3B. Sorry to interrupt.
Yeah, okay, we'll go back to 3B. Actually, let's go there first, otherwise I'll forget. Because I forget everything. 3B, oh yeah, because we had all that mess in there. All right, let me read the instructions one more time. Our instructions read, given that secant of theta is 5/3, and it's in the third quadrant between 270 and 360. Evaluate the following. want to find sine of 2 theta. And I did put a question like this on your exam. All right. So just to get an idea for sine of 2 theta, well, before we begin, make sure you have your unit circle handy because you're going to need it. And make sure you have your cheat sheet handy, either the one from your publisher, from your author's website, or the one I emailed you that's the back of another book. So you have all your formulas handy, whichever one you have, it's that one. All right, so sine of 2 theta, that is equal, or 2a, you use a, is 2 sine of a and cosine of a. All right, I need to find sine and cosine. But to find sine and cosine, I need to know the values that are made up by it. Now, secant is the inverse of cosine, right? And cosine theta is in terms of x, y, and z. Cosine is x over, not z, r, why did I say z? It's x over r. So secant, since it's the reciprocal, secant is made up of r over x. Right, you just flip it. So I need to find these 3 pieces. I need to find x, y, and r. Why do I need them? I need them because I need to find sine and cosine. Sine of a is made up of y over r, and cosine of a is made up of x over r. And from our given information, from what we have here, we have that r is 5 and x is 3. We're left to find that y. Okay, to find that y, I just have to go ahead and do Pythagorean theorem. Okay. So that we have x squared plus y squared equals r squared. I know x and I know r. So x is 3 squared. I don't know what y squared is, and r is 5 squared. So that we have 9 plus y squared is equal to 25 minus 9 minus 9. Y squared equals 16. Take the square root of both sides. Don't forget plus or minus. So y is equal to plus or minus 4. Do we want plus or do we want minus? Well, I have to look at my quadrant. That's what lets you know. So I have this triangle, right? My x is 3. All right, 3 is in the positive for x. My r is 5. R is hypotenuse, it's always positive. Now y, which is what we found, y has to be a negative because this is my negative side of my y. So we're left to choose -4. So y is equal to -4. That's why it tells you what quadrant you're in. All right, now I have to fill these pieces in the bottom. Sine is y over r. Y is -4 over 5. Cosine is x over r. X is 3 over 5. This is the hard part. Are you okay with setting this up? Now, in your exam, I do give you a hint. I say, make sure to find x, y, and r. Next, find the missing third piece by using Pythagorean theorem. Third, set up sine is equal to question mark, cosine is equal to question mark. All right. Last piece. Now we have this, 2 sine A cosine of A. So I have 2 times sine A. Sine A is -4 over 5. And times cosine of A, cosine is 3 over 5. We're just left to multiply. You get 25 over -24. And that's our answer. So this is the entire 3B. All right, now we have to continue with 5 or 6. Continue with where we left off at 5. Did we do 5? I feel like we did 5.
I believe
Yeah,
we
we
did.
did.
We did?
did.
Okay. Thank you. That's always fine. If you didn't catch it, you can always check out the video. It's all on YouTube. Question 6. Find all degree solutions for theta. Okay. All degree. So I'm just going to make myself a little note. I know because it's all that I need to add plus 360k when k is in the integers, right? So cosecant equals square root of 2. All right, so cosecant is square root of 2 at 45 degrees. Right. And it's also a positive square root of 2 at all students take calculus at sine. So it's also there. So our answer for theta would be 45 degrees. And 135 degrees. And we will write it as theta is equal to 45 and 135 plus 360k plus 360k, and k is contained in the integers. All right, let's continue with B. Tangent of -1. So tangent is 1 at the 45 degree mark, but I want -1. So we think all students take calculus. I want negative. It's negative in quadrants 3 and 4. So our answer would be 135 and 315. Those are our answers. So we can write it one or two ways. So our answer is 135 and 315. So we can write it to be theta is equal to 135 plus. Now, this isn't emphasized very highly, so be very careful. However, you kind of won't be tricked because it's in the multiple choice portion. Do you see how from here to here is 180? And at some point in our sections, we talked about how tangent and cosecant and secant, they have a period of 180 degrees. So it makes sense that it repeats at every 180 degrees. So you can also write it as 135 plus 180k when k is contained in z. So that's also another way to write it. All right, continuing with 7. Solve the equation 0, where x is between 0 and 2 pi, of 2 cosine squared x minus 1. All right, we want to solve for cosine. So let's go ahead and try to get cosine by itself. So let's do plus 1 plus 1. We have 2 cosine squared x is equal to 1. Divided by 2, divided by 2. And we have cosine squared x is equal to 1/2. Take the square root of both sides, and we have cosine of x is equal to plus or minus square root of 1/2, right? We can take the square root of 1, which is 1, and I'm left with square root of 2, but then I have to rationalize it. So really it's cosine of x is equal to plus or minus square root of 2 over 2. So I want all the answers for cosine when it's square root of 2 over 2. So our answers would be x is equal to 45. It wants radians. So it'd be pi over 4, 3 pi over 4, 5 pi over 4. Am I lagging a lot?
I have a question.
Uh-huh.
Why are we not going with square root? Oh, never mind. I got it. There's no square root of 1/2. I just saw that. Never mind. So
It's okay. And you'll catch that. You'll be like, okay, it's 1 over square root of 2. I don't find it. What happened, right? But what's going on is in math, we always rationalize. So if your answer never looks like what's in the back of the book or it's not matching up, maybe we didn't rationalize. That always happens. I tutored for many years, and that was the big stinker in trigonometry, not rationalizing your work. But good question. Thank you for pointing that out. Now, one thing we have to check, so I'll highlight it because yes, these are answers. That's when cosine is square root 2 over 2. But because we took the square root of both sides, whenever we take the square root of both sides or we square, we have to check our work. So something you must do is check your work for those problems. I won't check it with you because it'll be here forever, but be very careful. All right, let's continue with 8. And you have these answers online too, but I just want to work it out with you. Solve the equation for 2 cosine squared plus 5 sine plus 1 equals 0. All right, the problem here is that cosine squared. I want to be able to just have sine, unless I'm factoring. If they're being multiplied, then I can factor and that's not a problem. But because I wouldn't have to factor, I can't factor with that cosine squared yet. Let's replace it. Because I see that square, I should be thinking Pythagorean theorems, right? And we know that cosine squared theta is the same thing as 1 minus sine squared theta. So let's replace cosine with 1 minus sine squared. So I have 2 times 1 minus sine squared theta plus 5 sine theta plus 1 is equal to 0. All right, now I'm left to distribute that 2. So that I have 2 minus 2 sine squared theta plus 5 sine theta plus 1 is equal to 0. Combine like terms, I can go ahead and add that 2 and that 1. So I have negative 2 sine squared theta plus 5 sine theta plus 3 is equal to 0. All right, all those signs are making me freak out. We can change sign with W. So let's say W equals sine theta. So it gives me negative 2W squared plus 5W plus 3 is equal to 0. All right, let's factor. I need to do that factor tree thing. So negative 2 times 3 gives me negative 6. My middle term is 5. I can multiply to get 6 and add to get 5 using 6 and 1, where 1 is negative. So that factors to be negative 2W squared plus 6W minus 1W plus 3 is equal to 0. If I group my first two, I can factor out minus 2W. This gives me W minus 3. I can factor a negative 1, which gives me W minus 3. So this factors to be minus 2W minus 1 times W minus 3. Okay, now I can change W's back to sine, not cosine. So we have negative 2 cosine theta minus 1. And I have cosine theta minus 3. Let's solve for each one. Say each one equal to 0. Is cosine ever have anything to do with 3? Is cosine theta ever equal to 3? No, that's not a real answer. So that one gets crossed off. All right, we add 1 to both sides and divide by negative 2. We're left with cosine theta is equal to 1 over 2, 1/2. When is cosine a half? Cosine is a half in, you want degrees. Cosine is a half in 60.
Professor,
Also a half at 300. Yeah,
how come you changed it to cosine and we were doing sine?
because I'm on drugs. Because I made a mistake and I don't know, my brain wasn't working. It should be sine. But I mean, our work is not wrong. We said that, no, I'm not on drugs. So we have sine is equal to, we got negative 1/2. And we said sine theta is 3. If we change each one back to sine. So we still did most of the hard work. So my internet connection is really bad right now. For some reason, my writing isn't showing up on the Zoom. What if I write more? Will that help? Can you guys see my writing in the black pen?
Yeah,
Yeah, okay.
just the smiley face, but not whatever else you may
You don't
have
see
written.
sine? You don't see sine of negative 1/2?
I see that. Yeah, I
Okay,
see.
yeah. Okay, good. All right. So sine of negative 1/2, when is sine negative 1/2? Sine is your y. It's sine is negative 1/2 at 210. So theta is equal to 210 and 330. And that's our answer. All right, almost done. Let's just go ahead and finish. We have those two left. Number 9, solve the equation for 0 is less than or equal to x less than or equal to pi for 2 cosine of 3x minus square root of 3. All right, the big difference here is that my parentheses, my argument is not just x, it's not just theta, it's an actual argument, right? It's the expression dx. So because of that, I have to go through a same process but slightly different. So I have to change both my argument, my radian argument, my interval argument in radians, and I will also have to alter my answer. So first with your interval, we say it's from 0 to 2 pi, but we see here we want 3x. So I need to multiply by 3 to get 3x. So let's multiply all 3 sides by 3. So 0 times 3 is 0, less than or equal to 3x less than 6 pi. So this is our new altered interval. So my answer is going to be everything from 0 to 6 pi. Okay, let's go ahead and solve our equation. Instead of using that 3x, I'm going to write arg. And once I'm done, once I solve, I'll go back and change that arg to 3x. All right, so we want to solve for cosine. So I go ahead and add square root of 3, add square root of 3 to cosine of, I'm going to write arg is equal to square root of 3 divided by 2 to get cosine by itself. And we're left with cosine of arg is equal to square root of 3 over 2. When is cosine square root of 3 over 2? Positive square root of 3 over 2. All right, it's square root of 3 over 2 at 6 degrees, but we want radians, right? I'm sorry, at pi over 6, and that's 30 degrees. So arg is equal to pi over 6. And it's also square root of 3, positive square root of 3 at 330 degrees, which is 11 pi over 6. And that's my answer. Now, if we look at our interval, we don't want just one go around the circle. How many trips around the circle do we actually want? One trip is 2 pi. Another trip would be another 2 pi, so that's 4 pi. Plus another trip, that'd be 6 pi. So we want 3 trips around the circle, right? So we're going to add, to each one, we're going to add another 2 pi. All right, so add 2 pi to each. 2 pi, I want it in a common denominator, so we'll change that to the denominator of 6. So that'll be 12 pi over 6, right? So we're going to add 12 pi over 6 and add 12 pi over 6 twice, right? So all of our answers would be for arg would be pi over 6, 11 pi over 6. Now let's add that 12 pi. So we have 13 pi over 6, 23 pi over 6. That's one trip. Now another trip. So 13 plus 12. Oh, that gives me the same one. And 23 plus 12 gives me 35 pi over 2 over 6. All right, not done. We want to replace arg with that 3x. So we need to divide each one by 3. So you get x is equal to, now this is essentially multiplying by 1/3, right? So we have 1/3 times pi over 6, 1/3 times 11 pi over 6, 1/3 times 13 pi over 6, 23 pi over 6 times 1/3, and 1/3 times 35 pi over 6. So that all of our final answers are pi over 18, 11 pi over 18, 13 pi over 18, 23 pi over 18, and 35 pi over 8. Oh, I missed one. 13 plus 12 is 25 pi. So that would be 25 pi over 18. And this is one of your open response questions. Not exactly verbatim, but that's what you'll see. I see, Lance, that you don't have your mic turned off. Did you have a question?
No.
No?
Sorry.
Okay. No, it's okay. No questions before we move on? All right, let's take a look at the next one. Solve the equation for theta when it's between 0 and 360 for cosine theta sine theta of square root of 3 over 2. All right. So our algebra skills can help us here tremendously. They can help us because it won't be as hard or time consuming as the rest because we can essentially factor. So for 10, we see that cosine of theta and sine of theta are being multiplied, right? Everything's being multiplied. So I can go ahead and split it into, can we? I don't think we can, huh? All right, so let's look for an identity. We can do that when it's equal to 0, but not when it's equal to a number. That's the problem. All right, pulling out our identities. Which one does that look like? 2 sine A cosine of A. Oh, that looks like a double angle identity, right? So one of our double angle identities is sine of 2A is equal to sine of A times cosine of A. My original plan was I can split this into one, split that into the other, but we can only do that when it's equal to 0. The problem here, it's not equal to 0. All right, so we have to use our identity. So we can replace this with sine 2A. And then from there, we have to work with another arg type of situation. All right, so we want to take 2A and change also our interval. All right, so I have 0 less than or equal to theta less than 360. But you see how here has a 2 theta? I wrote A, but it should be theta. You have a 2 theta. I need to multiply by a 2 to make it a 2 theta. So we're going to multiply all 3 sides by a 2. So I get 0, 2 theta. 360 times 2 is 720. All right, almost done. We can replace that 2 theta with arg, or you can just keep it as 2 theta. So sine of arg is equal to square root of 3 over 2. When is sine positive square root of 3 over 2? So you take a look at unit circle, and you see that sine is positive square root of 3 over 2 at 60 degrees. And it's also positive square root of 2, oh, 3 over 2, I messed up. That was good. At 120. But we have, because we're multiplying by 2, we want 2 revolutions around the circle. So for each one, we're going to add 360. So 60 plus 360, we have 420. And 120 plus 360, we have 840. 480, not 840, 480. So those are our answers within 2 revolutions up to that. $720. Can I go another go around? No, huh? 420 plus 360, that goes over the 720. All right. Now we need to replace that argument with that 2 theta. 2 theta. I want theta by itself, so I need to divide all of them by 2. So that we have our final answer of theta is equal to 30, 60, 2, 1, 210, and 2, 4, 240. That would be our answer. Any question about this one? All right, almost done. Oh, I'm sorry. Question, Victor?
Oh, no, I'm sorry. I said no. Sorry.
Oh, okay. Almost done. 2 more. So let's not take a break and let's just finish these last 2. Unless you want to take a break, you can go run, grab some chips, grab your soda. Oh, I'm sorry, your sparkling water because they're healthy and they're grown up. All right. 11, find all degree solutions for theta. All right, so it's the same deal. We have an argument. A question here, 2 things you have to notice. We want all degree solutions. So we're gonna add that plus. I like to make a note because I forget everything. I really do. I know all degree solutions. I know I should have a plus 360k where k is contained in your integers. All right. And another second thing that might come into play is that, and it's not wrong if you forget. So if you forget this, it's okay. Remember, and you can always think back when you graph. When you graph, there are 4 types of graph that have asymptotes: cotangent, tangent, cosecant, and secant. So for those, because we have cosecant, it won't be plus 360k. It would be half of your answers, and it would be plus 180k. But if you do each one and add 360k, you're not wrong. You're just listing some twice. Does that make sense? But we'll see this. So let's go ahead and work this out. So cosecant for theta equals 1. Let's change that for theta to an arg. Now, I don't have an interval because it wants all solutions, so I don't have to worry about messing with it. I just need to find my answers within the 1 unit circle. So cosecant of arg equals 1. All right, so what is cosecant 1? I take a look at my unit circle, not just one, positive 1. And we see that cosecant is positive 1 only at 0, right? Only at 1 comma 0. Wait, I'm looking at the wrong one. At 90. I'm sorry, at 90, right? So cosecant is 1 at 90 degrees, only at 0 comma 1. So arg is equal to 90 degrees. All right, we want to change that arg to 4 theta. So 4 theta is equal to 90 degrees. Then we want to divide by 4 to get theta by itself. So we have an answer of theta is equal to 90 divided by 4 is 22.5. And that's our answer. Now, I made a mistake here. When we divide and we're using all answers, we have to also divide our 360k. Or yeah, 360k. So we have plus 360k that also gets divided by 4. So that would give us a plus 90k.
I don't understand why we're dividing the 360k by 4.
Because we're dividing that 4 theta. We want theta, so we have to divide by 4. So we divide by 4. And we also have to divide our 360. Everything has to be divided by that 4.
Okay, so instead of waiting till the last step to add plus 360K, we should add it when we replace the arg with 4 theta?
Mhm.
Okay.
All right, let's take a look at 12. Let me erase some work. All righty. 12. Find all radius solutions for x. And we're given square root of 3 cosine 3x equals 1 is equal to 0. Let's go ahead and solve for cotangent, but let's replace 3x with arg. So I have square root of 3 cotangent of arg minus 1 is equal to 0. All right, let's move some stuff around. Plus 1, plus 1. I have square root of 3 of cotangent of arg is equal to 1. Divide by square root of 3. Divide by square root of 3. So I have cotangent of our argument is equal to 1 over square root of 3. Now, if you look at a unit circle, if you look at your little box under unit circle, there's not 1 over square root of 3. So we need to rationalize. So once we rationalize, we get square root of 3 over 3. All right, when is cotangent square root of 3 over 3? It's at the 60-degree mark. So we have arg is equal, and I want all radiant solutions. So we have a plus 2 pi, right? Okay. All right, so arg would be equal to square root of 3 over 3 for cotangent. We said is 60 degrees. 60 degrees is pi over 3. And that would be it for cotangent. Because cotangent, like I was expecting to happen here, cotangent has a length of just pi, not 2 pi. Cotangent 60 pi over 3. Right, I'm not tripping, it's pi over 3, not pi over 6.
Yeah, I got the same.
Yeah, and the reason I'm saying is because just to be extra careful, I have the key, and I think that's an error in the key. It says pi over 6.
I see 240 degrees is also square root of 3 over 3. So that's 4 pi over 3.
4 pi over 3. Right, but that's just another pi difference. Can you still hear me or did you lose me?
Yeah, I hear you.
Okay, you just don't see my face? Oh, there I am. Okay, so we have cotangent. So all students take calculus. We want positive square root of 3 over 3. It's positive at the 60-degree mark, which is pi over 3. And all students take calculus. It would be positive again in quadrant 3 for tangent. And the 60-degree mark would be 4 pi over 3. But because we see that they're another pi away, you can just write it once and write a pi. You can write them both, and there's nothing wrong with that. That's okay. So we can say arg plus pi k instead of writing them both, since they're only a pi difference and they're going to repeat constantly having that pi difference. All right, last piece. We need to change that arg. So there's a mistake because in his thing he has pi over 6. I think he meant pi over 3. I thought I was doing something wrong. All right, so we need to change arg with 3x. 3x is equal to pi over 3 plus pi k. Last bit, we divide by 3, but since we have fractions, we can write times 1/3. That would work. Times 1/3 times 1/3. So we get x is equal to pi over 9 plus pi over 3k, when k is contained in your integers. So in the online key that your author has, this one has a typo. It says pi over 6, and I think he meant pi over 3. This is where the typo is. Yeah. All right, so we got over the entire review. And just to emphasize, in case something you want to see it written differently, you also have access to the key on, not DoorDash, at bobpryor.com. And you can go ahead and see the answers for your questions. So you can choose pre-test and answers. And this is actually test chapter 5, but it's all of chapter 5 and 6. And if you go ahead and click into the chapter 5 answers, it has them in bits, but you can see all of them there. And you can see all the work done. And it's not showing online, is it? It's frozen? All right.
I can see your screen just fine. Nothing's frozen.
Okay.
Yeah, Professor, it's looking good on mine. I wasn't sure if that's what you asked.
Okay, cool. So you can find the pre-test answers, and it has them in bits, but you can go ahead and look at them each one. And I'll also post this video online so you have access to it. And you can, see it presented again. Give me like about an hour and it'll be available. I want to talk about a bit more about your tests. So we did the review and almost done. I'll stop talking soon, I promise. And I want to tell you what it's going to look like. Your first question is going to look like this first part here, that matching one. Yeah. And then from there, you're going to have a series of multiple choice questions, and they're going to look like the rest of your exam. Kind of your review, kind of verbatim, like not same numbers, but same type of question. So have your review handy as you're solving these problems. You're going to have for sure some of these where you have to find that cosine and sine given some degree, right, that we did. Like number 3, you're going to see something. I know it's so messy to see with all my writing. You're going to see something like number 3, but I do give you a big hint. I say find x, y, and r. What is cosine and sine? Use the Pythagorean theorem. I do kind of walk you through it, and they're all multiple choice. With the exception of that first one, it's matching. I wrote down a column 1 and a column 2, and you just have to match them accordingly. And that's pretty much part 1. Part 2 is open response. Your open response will be 5 questions, each one with 5 problems. 3 of your open response questions will be solving equations, numbers like 7, 8, 9, 10, 11, 12, like those type of questions. You can expect that in your 3 of your questions. The other 2 are proving. So a lot like that first column, you have to prove one side is equal to the other side. And that's the second part. And that's your exam. They're both in 2 parts. I was going to put them into one large test, but I figured it'd be nice if you want to take a break after taking a part. It might be nicer. But you can do it continuously. Just take one test and then the other. For part 2, there is a file upload, just like before. And
Okay. So the picture, we could just take a picture and upload it again, right?
yep.
Yeah. So you would recommend printing that one out before starting it, because once we start it, we have to upload it, right?
One more time?
Once we start it, we have to upload it, or are we just
Yes.
uploading? Okay. All right.
Yeah, don't start it to get the question and then upload it because it won't be the same questions.
Okay.
Do they all have a
I
time
made-
limit?
Yes. The multiple choice, I made it, I believe an hour and a half because I understand that first matching might take you a while. I know
Okay.
identities are something that were very difficult when I took trig for the first time, right? So I am being aware of that, and I made you multiple choice. It's not too long, but just in case you struggle with identities, you have a bit more time to think and not feel so pressured. Your multiple choice is an hour and a half. Your open response, it's only 5 questions. I made an hour 15.
Sounds good.
So part A, which is, or part 1, which is multiple choice, you have an hour and 30 minutes, so 90 minutes. And part 2 is open response. You have an hour and 15. So within that hour and 15, you have to upload your work.
Okay.
On your multiple choice, I did give you, I think, I don't remember if I said 2 or 3 attempts for that one. But since it is multiple choice, you'll get your grade right after you're done taking it. And I think I allowed more than 1 try. But don't think your next try is going to be the same problems. They're going to be different problems. So take the first time seriously if you don't want to take another new test all over again a second time.
All right.
And your open response,
This was
it's
for
just,
this test, right? Not the final?
yeah, your final.
Okay.
We'll talk about that next week for your correct final.
All right.
All right.
And Professor, is the exam up yet? I'm sorry.
It's not up yet. I created it. Give me a minute to, give me like an hour or 2. I want to take the test over myself just to make sure there's no mistakes. So give me some time just to retake the test for you guys, just to make sure there aren't any typos.
Just out of
Because-
curiosity, Professor, how long does it take you?
To write tests?
Yeah,
Forever.
to do the test. No, to do the test like our test, like when you do it to check that everything's okay. Like when you take the test yourself.
This isn't, when I write a test, I hope that I can finish it. If I want you to finish it in an hour, I need to be able to finish it in 5 or 10 minutes.
Okay.
But this is because I know what we're doing.
Yeah,
I mean, I've done
no,
this
of
so many
course.
times.
Yeah, of course. No, I
So,
was just curious. I'm always curious with like professors, like when they do a test like this, like how long it takes them to like sit down and do it themselves.
and this is an
It's a
advice I got
testament to
from,
your guys' knowledge and how much you guys like have to do.
it's just
like,
what we
how
do all
long-
the time.
Yeah.
It's like, think about you driving and teaching someone not to drive. Isn't it a totally different experience? Because you drive all the time and someone who's learning how to drive doesn't even know how to turn.
Oh yeah, or
So-
getting in like a stick shift if you've never done that. Yeah, absolutely.
Yeah. So that's kind of like that. And I got this advice from a professor because sometimes I wouldn't even finish my tests. And I'm like, oh my gosh. And he's like, well, I think it's fair because it was an hour class. He said, I need to be able to finish this test in 5 minutes if I can expect you guys to finish it in an hour.
Okay.
And I'm like, oh, okay. So then that's kind of what I do as well.
Okay. Yeah. See,
And-
that's interesting.
But not all teachers do that. So
Yeah. No, I'm sure. But I was just curious as to you. And then one other thing, Professor, for the final of the pretest that we're doing right now, is that upload up, or are you gonna put that up as well?
the final?
To upload to upload this review.
Oh, to upload the review? I'll do it right now. I can do that right now. It takes me like 30 seconds.
Okay. All right. For sure.
I'll do that right now.
Is it the same as last extra credit?
Yeah.
5 points. Okay. Sweet.
Mhm.
Thank you.
All right.
Wait, sir, you're gonna upload the review from the Bob website?
Oh no, you can check that on yourself. So what I do is if you complete the review, I give you extra credit. Now we did go over every single one, but I figure that if you took the time to write it, I hope that maybe by some type of osmosis, it'll just stick in your brain better and you'll do better.
Oh, okay.
I don't know if that's even a thing.
Yeah.
All
No. Okay. So the document upload is what you're gonna put up, so we can upload it when we're done with it.
Yes.
Perfect. Thank you, Professor.
So again, if you do the review, you should be in good shape. It'll be fine. It's all the
Professor,
same stuff.
I had a question on the quiz on 6.1 and 2. Was that unlimited attempts or was it just one attempt?
It shouldn't have been limited. Did it lock you out?
Yeah, it muted me out after one attempt.
Same.
That was
The same on my end, Professor.
And I know I missed 2 because I was having a really hard time on them. So I had to guess. So I know definitely I got those 2 wrong, which
and that's
dropped my
6.1 and
grade.
6.2?
What was that?
6.1 and 6.2?
Yeah. The
Okay, I'll
quiz,
check
yeah.
that.
Thank you.
I'll send an announcement once I think I figured it out. And if I didn't figure it out, let me know and I can try to
Okay.
fix it.
Oh, also, where's the best to message you, on Canvas or an email?
Well, the Canvas emails go straight to my Outlook email, so you can just send me a Canvas email.
Okay, because I think it was like a week ago actually, and I hadn't heard from you. That's why I was
Oh
like, I'm just
no!
gonna ask him on the Zoom.
Oh my gosh! All right, I'll
Okay.
check my email for your name.
Oh, well,
That's
it
fine.
was the same question actually. You
Oh,
already
okay.
answered it. Thank you.
All right. Okay. All right. Awesome. So good luck on your test. If there's any major questions, email me. I check my email often. And that's it. I'll open up the extra credit review option so you can upload your extra credit review. Completed
Thank you,
review.
Professor.
Thank you.
See you
All
on
right.
Thank
Tuesday.
you. Bye.
See you Tuesday. Bye-bye.